Swastiastu, Namo Buddhayo, Salam Kebajikan. Thank God for the gift so that I can present chemical equilibrium material in this video. So, allow me to introduce myself. My name is Sawaludin LAKORO. My nickname is Haikal or Sawal. I'm from North Sulawesi. My study program is Physical Education, Class A, Student Identification Number 421422017. According to the title of my presentation on chemical equilibrium, so let me clarify that chemical equilibrium refers to a state of a system in which the concentration of reactant and concentration of product not change with time and the system does not show any future change in property. So let me present my material. Chemical equilibrium title. What is chemical equilibrium? Chemical equilibrium refers to the state of a system in which the concentration of the reactant and the concentration of the product not change with time and the system does not display any future change in property. So, when the rate of the forward reaction is equal to the rate of the reverse reaction, the state of chemical equilibrium is achieved by the system when there is no future change in the concentration of the reactant and the product due to the equal rates of the forward and reverse reaction. The system is said to be in a state of dynamic equilibrium. Why is chemical equilibrium called dynamic equilibrium? The state at which the rate of the forward reaction is equal to the rate of backward reaction is called an equilibrium state. At this point, the number of reactant molecules converting into product and product molecules into reactant are the same. The same equilibrium can be carried out with the same reactant anywhere with similar condition with continuous interchanging of molecules, hence chemical equilibrium is dynamic. A chemical equilibrium is called a dynamic equilibrium because the reaction continues to occur both to the right and to the left at the same rate. Thus, a chemical equilibrium is said to be a dynamic equilibrium because the reaction continues in both directions at the same rate. Chemical equilibrium are all in the same phase. Homogeneous equilibrium can be further divided into two types. Reaction in which the number of molecules of the product is equal to the number of molecules of the reactant. For example, H2 in bracket G plus I2 in bracket G makes to HI in bracelet G and 2 in bracket plus O2 in bracket G yields to NO I in bracelet G. Reaction in which the number of molecules of the product is not equal to the total number of reactant molecules. For example, 2SO 2 in brackets G plus O2 in brackets G makes 2SO3 I in bracket G COCl 2 in J brackets CO in 2 brackets plus Ci2 brackets G heterogeneous chemical equilibrium. In this type, the reactant and the product of chemical equilibrium are present in different phases. A few examples of heterogeneous equilibrium are listed below. Thus, the different types of chemical equilibrium are based on the phase of the reactant and product. Factor affecting chemical equilibrium. Chemical equilibrium factor affecting equilibrium. According to the Le-Chatelier principle, if there is any change in the factor affecting the equilibrium condition, the system will counteract or reduce the effect of the overall transformation. This principle of application to both chemical and physical equilibrium. There are several factors like temperature, pressure, and concentration of the system which affect equilibrium. Some important factors affecting chemical equilibrium are discussed below. Next, change in concentration. First, the concentration of the reactant or product added is relieved by the reaction which consumes the substance which is added. The concentration of reactant or product removed is relieved by the reaction which is in the direction that replenishes the substance which is removed. When the concentration of the reactant or product is changed, there is a change in the composition of the mixture in chemical equilibrium. Step 2. Change in pressure. Change in pressure happens due to the change in the volume. If there is a change in pressure, it can affect the gaseous reaction as the total number of gaseous reaction and product are now different. According to the Chatelier principle in heterogeneous chemical equilibrium, the change of pressure in both liquids and solid can be ignored because the volume is independent of pressure. Step 3. Change in temperature. The effect of temperature on chemical equilibrium depends upon the sign of the reaction and follow Le-Chatelier's principle. As temperature increases and the equilibrium constant of exothermic reaction decreases, in an endothermic reaction, the equilibrium constant increases with an increase in temperature. Along with the equilibrium constant, the rate of reaction is also affected by the change in temperature. As per Le-Chatelier principle, the equilibrium shifts towards the reactant side when the temperature increases in case of exothermic reaction. For endothermic reaction, the equilibrium shifts toward the product side what increase in temperature. Next, effect of catalyst. A catalyst does not affect the chemical equilibrium. It only speeds up a reaction. In fact, catalysts equally speed up the forward as well as the reverse reaction. This results in the reaction reaching its equilibrium faster. The same amount of reaction and product will be present at equilibrium in catalyst or a non-catalyst reaction. The presence of a catalyst only facilitates the reaction the process through a lower energy transition state of reactant to the product. Next, effect of addition of an inert gas. When an inert gas like argon is added to a constant volume, it does not take part in the reaction. So, the equilibrium remains undisturbed if the gas added is a reactant or product involved in the reaction, then the reaction content will change. Next, problems on chemical equilibrium. 1. The equilibrium constant Kv for the reaction N2 in brackets G plus 3H2 in brackets G gives 2NH3 in brackets G. AS 1.6 times 10 min 4 atm min 28400 degrees Celsius. What will be the equilibrium constant of the chemical equilibrium at 500 degrees Celsius if the head of the reaction at this temperature range is KCl? Solution. Equilibrium constant at different temperature and head of the reaction are related by the equation. Log Kp2 equals minus 25,140 divided by 2,203 times 2 in bracket 7 Qn 17 3 minus 617 3 plus log 1.64 times 10 min 4. Log Kp2 equal min 4.835, Kp2 equal 1.462 times 7 minus 5 atm min 2. 2. Given the equation N2 in brackets G plus 3 H2 in brackets AQ gives 2 NH 3 in brackets G, find K and determine which direction will shift in order direct the state of chemical equilibrium. Solution. Given in brackets N2 equals 0.04 m, in brackets G, in bracket H2 equals 0.09 and K equals 0.040. Since only nitrogen and hydrogen concentration is given, it can be assumed as the reactant and ammonia as the product. Since the ammonia concentration is not given, it can be assumed to be 0. As K is the ratio of the relative concentration of product to reactant, here K equals 0. Since K equals 0.04 is larger than K, nitrogen and hydrogen will combine to form product ammonia. Thank you.